To get the derivative of cosecant, we write it as the reciprocal of sine, and then we can use quotient rule. I've got the work written out here. The result of that is negative cosecant of x times cotangent of x. One thing I should point out, both trig functions have an x. Same thing here, secant x times tan x, each trig function has an x. Important that you write that, otherwise, if I didn't have this x here, that would mean secant of tangent of x rather than secant of x times tangent of x. Same thing here. I want that to be the product negative cosecant times cotangent. Okay. Now, at the end of this video, I'll leave this work up for those of you who want to review it. It's very similar to the work that we did in finding the derivative of secant. I want to just talk a little bit about these 6 formulas and point out a couple of things that make it a little bit easier to remember all of these formulas. The trig functions sort of come in pairs. Derivative of sine is cosine, derivative of cosine is negative sine. Okay. Tangent and cotangent follow a similar pattern. Derivative of tangent is secant squared, derivative of cotangent is negative cosecant squared. Secant and cosecant follow a similar pattern. Each is a product. Derivative of secant is secant times tangent. Derivative of cosecant is negative cosecant times cotangent. Okay. So there's sort of 3 patterns, each of which applies to a pair of functions. The other thing I'll mention is that if there is a co in the name of the function, cosine, cotangent, cosecant, there is a negative sign in the formula for the derivative. So 3 of the formulas have a negative sign. Those go with the 3 trig functions that have a co in their name. You can also, we discussed this a little bit with sine and cosine, you can use the graphs to remember things. Tangent, I know that tangent is always increasing. So its derivative had better always be positive. Well, secant squared is always positive. Cotangent, that's always decreasing. So its derivative had better be negative, so it's the opposite of something squared. This derivative is always negative. Okay. So that can be helpful in remembering that here. We could certainly graph secant and then sketch its derivative. Don't think that's super helpful here. Here I sort of rely on the mnemonic that if there's a co in the name, there's a negative in the formula for the derivative. Okay, so I'm going to stop talking now. I'm just going to leave the camera on for a minute so that if any of you wanted to check your work in working out the derivative of cotangent, you have a little bit of time to do that.